Hello everyone. We are presenting on object-oriented programming differences between C++ and Java. The presenters are Chaitra and Vipra. I'll first start speaking on differences in data types and wrapper classes. There is no copy constructor in Java, no destructors in Java, nested classes, and polymorphism. Java has only 8 primitive data types. Those are byte, short, int, long, float, double, boolean, and char. Whereas C++ offers a rich assortment of built-in and user-defined data types, such as bool, char, int, float, double, void, and void char t. And you can use modifiers like signed, unsigned, short, and long with these data types. So you get a rich assortment of data types in C++. However, Java has no struct or union types like C++ does because these are maintained using classes in Java. We shall look more into in object-oriented programming environment. Java provides wrapper or helper classes that support these primitive data types, and we shall look more into these primitive data types and wrapper classes in the next slide. A primitive wrapper class is a class that encapsulates or wraps data types from 8 primitive data types so that these can be used to create instantiated objects with methods in another class. These primitive wrapper classes are found in Java API. The primitive wrapper classes are used to create an object to represent primitive types in collection classes. In object-oriented programming, a wrapper class is a class that encapsulates types so that these types can be used to create object instances and methods in another class that need those types. So Java provides these primitive wrapper classes, and here you can see the different 8 different data types and the wrapper classes for those 8 different data types. For example, if you are using float, the wrapper class begins with a capital F, and the constructor arguments can be float, double, or string. Converting primitive data types into object is called boxing, and this is taken care by the compiler. For example, in this code, you can see integer. Here, the integer x is equal to 10. This line boxes an int to an integer object, and the next line where you're adding 10 to the integer object unboxes the integer to an int. And therefore, while using wrapper class, you just need to pass the value of the primitive data type to the constructor of the wrapper class, and the wrapper object will be converted back to a primitive data type, and this process is called unboxing. And here the integer, long, float, double, byte, short, all these wrapper classes belong to the subclasses of a number class. The next point to be covered is there is no copy constructor in Java. So a copy constructor is a member function which initializes an object using another object of the same class. Though constructor usage is same in both C++ and Java, if a constructor is not defined, a default constructor is called. However, there is no copy constructor in Java because all the objects of the class are passed by reference in Java. And this is how you define a copy constructor in using C++. And next we'll move on to no destructors in Java. So in C++ we need to code an explicit destructor whenever the constructors allocate memory. If a constructor for a class allocates a memory, then the destructor for that class should free that memory. The destructor has the same name as the class but is prefixed with a tilde symbol like this. So you have to manually write the code to free the resources in C++. However, Java does not require any destructors. The garbage collector in Java examines the active references to an object and frees the storage when no such references exist. So this eliminates memory management bugs. Next, let's see nested classes. Java allows us to define a class inside of another class. This class is referred as an inner class. In Java, the inner class has a secret this member which remembers the instance of outer class to which it was bound. C++ also has nested classes. However, there are different variants in which you can define an inner class in Java. Java provides two types of nested classes, that is static and non-static nested class. So here are some examples of Java nested classes. The first example on the left hand side is inner class defined directly inside the outer class. Here you can say inner class is defined as a member of the outer class. In the second example, you can see the inner class, it belongs to one of the methods in the outer class. So there are two types of nested classes. Static nested class, it has a static modifier applied to it. Static nested classes can only access static members of its outer class. These classes cannot refer to non-static members of its enclosing class directly. Non-static nested class is also known as inner class. They have access to all variables and methods of outer class, including its private data members and methods. However, the reverse is not true. The outer class cannot directly access members of inner class. So in this example, this is an example where inner class is defined directly as a member of outer class, but the inner class is instantiated outside the outer class. So you can see that there is a separate class called test where you're calling outer class dot inner class and you're creating a new object of inner class, and this is done outside your outer class. So this is how nested classes work in Java. Next, let's move on to polymorphism, the differences of in Java and C++. Both the languages provide support for polymorphism. However, they have different syntax on how to enable it. In C++, you have to make use of the virtual keyword in the base class. In Java, the virtual keyword is not required because in Java, all methods are virtual by default. So hence, no extra keywords are required to enable polymorphism. Without the virtual keyword in C++, the methods are plain member functions and they do not allow or follow the rules of polymorphism during dynamic binding. With virtual qualifier, you get methods which use dynamic binding. However, in Java, all methods are virtual by default and you always get polymorphism no matter what. So here is an example of polymorphism in C++. So here you have base class and you have used virtual keyword in the base class. Then you are having a derived class that is deriving from public base, and you have over written the function fun. So when you run this code, the output you get is when you create a new base object, you get base is fun, and when you create a new derived object, you get derived is fun. So it is overwritten. And on the right hand side, you get there is an example of a polymorphism in Java. So where a vehicle class has the method move, and it prints vehicles can move, and motorbike it extends. You use the keyword extends vehicle, and you are writing defining move again with this output. So when you define the classes, when you define the object here, dot move from the vehicle object prints motorbike can move and accelerate too, and the new vehicle which you create, it can print from the base class, that is the vehicles class. So this is how syntactically it is different from C++.
Hello, I'm Vipra. Let's move on to the second section of this video. I'll be talking about global functions, multiple inheritance, and access specifiers, both in data members and in the classes. Uh, okay, global functions and variables. So in C++, as you would know, that we have global functions, and as C++ is not totally object oriented, it allows the making of global functions and variables. Global variables in C++ are created outside any function, usually at the beginning of the file, just after the includes. They are sometimes confused with hash-defined variables, but global variables value can be changed by any function in the same file or by including that file in another file. They are not very popular as it has global scope, and which means that any function can modify the value of those variables. Global functions, on the other hand, are just normal functions which don't belong to any of the classes, and and they're not defined inside any of the classes and can be accessed directly from anywhere. Although, as Java is fully object oriented, Java does not allow the creation of global functions or variables. Every function or variable in Java has to be inside a class, even if it is a main function. When we create a data member or a member function as static, that data member of the class can be accessed directly by using the class name and not object. Hence, it kind of provides a feeling of giving a global variable or a function, but actually it is not global. That static member is shared by all the objects, and so the value of that data member is shared. Let's see this example. As you can see, I've created here a class called static example, and I've created another class, which is static example 2. I've created a variable called tags, which is static, and another one called calcost, which is also static. I'm creating an object of this static example 2. I'm not creating, I'm directly using the static variable of this class in the other class, and I can call it directly on the class name as it is static. Hence, in the initially, the value will be 3.5. Then I can modify that value as it is public and can be directly modified. And then if I print, you can see the value changes. Also, the same way, I can call this function calcost over the class name, and I can pass whatever data members it needs, and it will again return the value it's supposed to. Hence, both of these are providing kind of a global feeling, but it's not really totally fully global. Next is multiple inheritance. As you know, inheritance is an important pillar of object-oriented. It is the mechanism by which one class is allowed to inherit the features of another class. The features being the fields, the data members, and the member functions. Multiple inheritance means that one class can have more than one superclasses, and the derived classes inherits the data members and member functions of both or all its parent classes. C++ allows a class to inherit the properties of multiple classes. As you can see in this picture, class D, that is a derived class, is inheriting the features or properties of class A, B, and C. In this example, I've created one class called mammal. It just has a constructor. Another class called water animals. It again have a constructor which prints something. And then this class called whale is inheriting the mammal class, which is this, as public, and the other one, water animals, as private. We'll be talking about these access specifiers in the coming slides. So when I create this constructor, how it works is the constructor of mammal is called first, then the constructor of water animals, and then finally the constructor of whale. When I create a object of whale, this is how it will print out all the three of them. Hence proving that multiple inheritance is allowed in C++. On the other hand, in Java, it does not support multiple inheritance with classes for the reason of simplicity. That is, they didn't want the diamond inheritance problem anymore, and so that there is no ambiguity, because if multiple classes, as you can see here, if both these classes implement the function of A and then D inherits it, D will not know which one to use, the one from B or one from C, because they're at the same level. So, and also because multiple inheritance in general is rarely used. Another reason is because in multiple inheritance, two classes, yeah, we already talked about that. It might define different ways of doing the same thing. So the class B can call something, say print function, and it prints something else, and class C has the same function print and it prints totally something else. So the derived class, it becomes really ambiguous which one it will get inherited. Although we can get somewhat close to this concept of multiple inheritance through the use of interfaces, as interface only defines what that class does and not how it achieves it. That is, by it does not tell you the implementation, it just tells you that there is gonna be this feature. So when a class is using multiple interfaces, when it is implementing multiple interfaces, it is not inheriting them, but instead it is implementing them and adding the properties and behaviors as it is required by that class. Hence, it is not getting the implementation free from the parent class, but the child class is actually just doing writing the implementation by itself. In here, you can see that we have created two interfaces, one called brick, another called cement. And then I have created one more class called house that implements the brick and the cement. Now the brick has one function called a get number of bricks, and then cement has get cement weight, but both of them are not implemented. When I implement it in the house class, we have to override these two functions in this house class, and the implementation is written in this derived class, in this class. So when I create an object of the house, and then I say, okay, object dot get cement weight, the implementation is of its own class, and there is no implementation that is written in the brick or in the cement class. Now we'll talk about the access specifiers. So access specifiers just tells from where the class data members or the member functions can be accessed. Irrespective of the access specifier, all class members can access all of its members. So the three access specifiers in C++ are private, protected, and public. Best practice is to use the most restrictive access level that makes sense to a particular member. Usually use private unless you have a good reason not to use it. Also, all data members of a class are usually kept private, and we make getters and setters if we really need to provide some kind of access to that data member. Public data members are usually avoided unless it's a constant value and hence cannot be changed from outside. Private members of a class are never accessed from anywhere except the member of the same class. The protected members cannot be accessed from outside the class also, just like private. But if a class inherits this class, then they will be inherited too as protected members. Public members can be directly accessed through any object from anywhere. Now coming to the inheritance, if the base class is getting inherited as a private, as if you remember, we were specifying this private in here, then all the members of base class are inherited as private in derived class, irrespective of the access specifiers in the base class. Whereas if the class is inherited as protected, all the public and protected data members of the base class are inherited as protected in the derived class, but the private ones remain as private still. When a class is inherited as public, the access specifiers remain the same in derived class as they were in the base class. So, yeah, in Java, we have all the three access specifiers that were there in C++, but we add one more, the default one, which gives the access at package level. The Java docs provide this amazing table to really see how the access specifiers work in Java. The public remains same. It can be accessed throughout. Protected cannot be accessed through outside the world. If it is private, it cannot be accessed from anywhere but only within the class. But the no modifier or the default one can be accessed through the package also, through the package classes also. Here are really two good examples, but let's see first. So the Java, the access specifiers can also be used to specify the access specifier for the class or the interface definition. So we can use default, that is, do not specify anything, or we can use public in front of the class name, and it will give you some kind of access specification for that class also. For example, in this example, you can see I've not defined any access specifier here. That means this class object can be made only from within the package. That is, it has a default access. But whereas in this one, it can be accessed. An object of this class can be made from anywhere in the project. Okay, that was all, and hope you enjoyed this video. Thank you.